Okay, so good morning. This morning I will be discussing to you the laboratory exercise number 3, which is collision lab. So I will show you the lab exercise, and then later on I'm gonna show you how to navigate the um, PhET simulation through our ano, wait lang. Share sa ako. Share lang na ako entire screen. So this is the lab exercise number 3, collision lab. So last meeting, we already discussed momentum. So basically, momentum is defined as the mass in motion. So from that definition alone, we can know that momentum is dependent upon two variables, mass and velocity. In formula, we write the quantity momentum using the lowercase p or small letter p. So that is equal to m times v. So the unit for momentum is kilogram meter per second because the SI unit for mass is kilogram and the SI unit for velocity is meters per second. So at the end of this laboratory exercise, we can be students will be able to compute for the momentum of the object given its mass and velocity, or by computing its component velocities. Compute for the resultant velocity of a colliding object, resultant meaning the ending velocity, or the component velocity. So for example, your object is moving at an angle. Now, if we will plot the movement or the path of the moving object in a x and y coordinate system, and the path is or creates an angle, so we have first to compute or to solve for the resultant velocity before we can compute for the momentum. Okay, differentiate the momentum of objects with varying elasticity after collision. Um, Later on during the conduct of our experiment, we can determine or we can know that that elasticity has a factor. We compute for the kinetic energy of an object given mass and velocity. So last meeting we have I have also shown to you the formula to compute for the kinetic energy of an object using its mass and velocity. So ganito yung atong formula for kinetic energy, that is 1/2 mv squared. So the unit for kinetic energy is kilogram meter squared per second squared. So now let's go to the procedure. So if you click this link, actually this link can also be seen sa atong VSU EE. Just go to our ESci 114 virtual classroom, go to laboratory exercise number 3, and there are two links here. You can go to either of these links. So ini-click ninyo ani, dalhon mo ani nga page. So part 1, introduction, click on the intro tab. So we have 4 tabs here: intro, explore 1D, explore 2D, and inelastic. So we click on the intro tab, and this is what will appear on our screen. Adjust the buttons and boxes in the top right panel. Explore what each tick box shows in the simulation. So when you click on the velocity, okay. So initially, if you uncheck the velocity, you can also only see two objects, no? 1 and 2. When you click the velocity tick box, you can see that nana siya velocity component. So the longer the arrow, the higher will be the velocity. When you click the momentum, it will also show you okay. Okay, if you click the momentum, it will show you the blue arrow showing the momentum of the objects, of the two objects. As you can see, mas dako ang momentum ni object 2. Although they are not moving yet, no, because wala pa nato gi-click ang play. However, from the knowing that momentum is affected by both mass and acceleration, mass and velocity, ma-compare nato nga mas dako ni siya og mass kaning object 2. That's why mas dako siya og momentum. We can also check the change in momentum. Later, it will show us when we click the play button, the change in momentum will show us the change in momentum. Okay? Sample lang, sample. So that is the change in momentum. Kaning blue nga arrow nga mo appear diri sa ibabaw. So makita nato nga mas asa may mas dako og change in momentum nilang duha. Reset. Center of mass, kinetic energy. So diri makita ang kinetic energy, 0.44 joule initially, and the values. So when you click the values, the initial value of the velocities and the kinetic velocity and the momentum are being shown. Also, we have here the more data. When you click the more data, all of these values will be shown in a tabular form. So you have here for mass 1, initially its mass is 0.5 kilogram and its position is at -1. So for example, we plot it in a x and y coordinate system. So its position at x is -1. Therefore, its velocity along x is 1. So knowing its velocity and mass, we can compute for its momentum. So that is 0.5 times 1, that is equal to 0.5 kilogram meter per second. For the second mass, that is which is 1.5 kilogram times 1, times velocity, which is 0.5. So therefore, its momentum is 0.75 kilogram meter per second. So the negative sign here signifies its direction, that is going to the negative x-axis. So when you sum up the momentum, imong atong i-deduct or atong ni siyang i-minus, no? We can sum up momentum because from the definition there is a law of conservation of momentum, so therefore we can sum them up. However, the second object is going to the negative x-axis. Therefore, this is ato siyang i-minus. So ang resultant niya nga kung atong i-sum up ang ilang momentum, that is 0.5 minus 0.75. So ang mabili nilang is 0.25, or ang katong 25 is going to the left. Okay. So that is okay, sa inyong lab report, you have to answer this one. Upon clicking the play button, what happens with the ball? So initially, the ball will collide, and after collision, they will change their velocity and direction. However, ang ilang kanang final velocities kung ang ilang final momentum kung atong i-sum up will also sum up to the initial momentum, di ba? Ang atong initial momentum is pinaman 0.25. Ang atong final momentum is or should be 0.25 also. So that is 0.63 or negative 0.63 plus 0.38. So that is also negative 25. So therefore, na-prove na to nga there is a conservation of momentum. Okay, second question, still under 4, which of the two balls travel faster after collision? What are the factors that affect this behavior? So after collision, asa naman nilang duha ang mas taas og velocity? Kaning number 1, because initially they have to conserve the momentum, and because momentum is a quantity affected by mass and velocity, mas gamay ang mass, so therefore kinahanglan mas dako siya og velocity or mag-result siya og mas dako nga velocity. So ang iyang velocity now is negative 1.25. Next, number 5. Click the button More Data to see how the differences in mass and velocity affect the momentum during collision. So, muna siyang atong gihimo a while ago. Number 6, run the simulation. Notice that you can adjust the initial conditions of the two balls. Also notice that you can slow down the collision by adjusting the time-lapse slider. Try a few different scenarios. So we can adjust by clicking the balls and moving it around. As you can see, it's just moving along the x-axis because napamata sa intro. Later on, sa kaning Explore 2D, we can already move the balls in different directions along the x and y. But for the intro, along x lang sa ata. Aside from moving the ball, you can also adjust the velocity by moving the arrow. Click and drag, click and drag. We can adjust the velocity, click and drag. We can also adjust the position and velocity by clicking on this More Data nga box. We can also adjust the mass. So just input like, for example, the mass 1 is, let's say, 3 kilograms. Enter. Mas dako na siya. Si mass 2, let's say, 0.25 kilograms. So the range of the masses should be from 0.1 to 3 kilogram only. Okay. So explore and analyze what is happening or what changes are happening sa ilang momentum and velocity. Number 7, reposition the balls in such a way that they are 0.5 meters away. What difference will this adjusted distance cause the balls in terms of their final velocities or velocities after collision and momentum? So refresh. Kani nga refresh, it will refresh all di ba ato magi-change ang ilang mga masses. So kung kani siya nga button ng atong i-press, it will reset to the initial mass nga atong gi-change. Okay. So ato ko nung i-position ang duha ka balls wherein ang ilang distance is 0.5. So atong i-position si ball 1 sa 0 and si ball 2 sa 2. 0.5. So ang ilang distance karon between each ball is 0.5. If we play, what is the effect of changing the distance sa ilahang momentum? Number 8, notice the change in momentum after collision and explain the change in the momentum. Again, ang atong baseline here is we should identify or we should see sa simulation the law of conservation of momentum. Once you are already familiar with the simulation, go to the second tab labeled Explore 1D. Sa Explore 1D, na ay one additional feature here, which is the reflecting border, wherein the ball can bounce to the border after the first collision. When we click on Explore 1D, same lang gihapon sila og interface. So nara sila reflecting border nga na-add, wherein ini-click na to, mo bounce na siya sa atong border. Okay? And from here, we can also add more balls. But for the sake of comparing the momentum para mas dali rato ma-analyze ang changes sa ilang momentum, ang input ug ang ilang velocity, ang atong gamiton lang ay 2 balls. Explore this tab by changing the masses, that is number 10, no? Position and velocities of the ball. And after familiarizing with the Explore 1D tab, go to the third tab labeled Explore 2D. This part of the simulation will allow you to set the balls to start moving in different directions. So sa intro and sa Explore 1D, if you click the More Data button, you only have the X position or the position of the balls along the X-axis. However, for Explore 2D, if you click the More Data, na siya duha ka positions, which are the X and Y positions, or its position along the X with reference to the X and Y axis. Okay? You can also increase the number of balls to at most 4. However, as what I've said earlier, for this laboratory exercise, we will just explore collision scenarios for only 2 balls for better understanding of the principles of conservation of momentum. However, if you have finished exploring or if you have mastered or nakabalo na gid mo kung say mahitabo sa momentum between the collision of 2 balls, you can increase it by to 3 to 4. Maximum of 4 ni siya. You can also, as you can see here, you can also show the grid line so that makabalo yun ta sa ilang mga positions if we will plot them in an sa X and Y coordinate system. Knowing that the scale of this big box here or big square here is 0.5 meters. That means the distance from this point to this point is 0.1 meter. For part 2, experiment. So using the table below, record 8 different collision scenarios. But be sure to include trials where A and B have the same mass, where A and B have different masses, where A and B are heading in the same direction, and where A and B are heading in different directions. Show all your computations in your lab report. So we have here 6. So the first 2, ang inyong sample here, same ang ilang mass sa A and sa B, or sa ball 1 and sa ball 2. For 3 and 4, different masses, but they are heading on the same direction. For example, ang ilang velocity are going the same way. And for mass 5 and 6, their direction are different directions na sila. For example, different directions, okay, Since we have the reflecting border, moabot yun ang time nga mag-collide silang duha. As you can see, samtang wala pa sila nag-collide, their velocities wala nag-change, no? Wala nag-change ang ilang velocity. But once they collide, mag-change na ang ilang velocity. We can also show this the slow motion way para mas makabalog kita sa changes sa ilang velocity once they collide. Normal mode. Slow motion mode, normal mode. And as you can see, kung if maigo sa ball ang kanang reflecting border, ang iyahang velocities, ma-change lang ang iyang sign. So therefore, dili ma-change ang ilang velocities. Ang sign lang ang mag-change. So that indicates that the change will only be the direction. Because if we will solve for the velocities, okay, how can we solve for the velocity? Example, mo na siya iyang velocity. To solve for the velocity, we can use the formula, Pythagorean the formula, kabalo naman nga formula, kanang a squared plus b squared is equal to c squared, or the velocity along the x, or the x component of the velocity squared plus the y component of the velocity squared is equal to the final velocity or the resultant velocity squared. So inig-square ninyong duha, aning duha ka values, inyong i-add din atong kuhaon ng square root. So that is your resultant velocity. So you have to input here your initial velocities for both mass A and mass B. And you have to compute for the momentum, P. P is momentum, di ba? P for mass A and mass B before collision and after collision. So this is kanang first collision nila. Also take note that this one is for collision with 100% elasticity. Meaning, your objects or your balls are elastic, 100% elastic. So asa nato makita ni siyang elasticity? Dire. So the elasticity here is at 100. We can also change the elasticity to a minimum of 5%. So dili siya mo 0%. Puto ba siya 5%? So what will happen if the elasticity is only 5%? So dili na siya mo bounce. Reset. Atong padaktasan ang ilang velocities and play. As you can see, if the elasticity is 5% and i-bounce niya sa wall, hinay ang iyang velocity because dili siya elastic. Inelastic na. Reset at elasticity 100%, atong replay or i-play balik. Okay. So basically, if your elasticity is 100%, your velocity or your resultant velocity will not change. Okay, next, change the setting so that the elasticity slider is set to 5%, which is the lower limit. And repeat the simulation for the data. So you will also be using the same set of mass and velocity from number 13, kaning procedure number 13. Same mass and initial velocity ang inyong gamiton sa table 2. Ang magkalahi lang nila is the 5% elasticity, no? Kaning elasticity. Ang sa table 1 100%, sa table 2 5%. But their initial velocities and masses will still be the same. For part 3, observation and analysis. Question number 15 or item number 15 is a question which you have to write on your lab report. Can momentum be transferred to another body upon collision? Based sa ato ang observation a while ago, the answer is yes. Diba? Nakita nato nga si small mag-change ang ilang momentum. However, when the momentum changes, they still sum up, or kung imo silang i-add, mo sum up gihapon sila sa ilang initial nga momentum before collision. So again, mag-change ang ilang momentum, but the momentum will just be transferred from one ball to another. Number 16, in terms of kinetic energy or KE, fill out the table below using the data you used from table 1 in the 1D simulation. Show your computations on your lab report. Can kinetic energy be transferred from one body to another? So, how can we solve for the kinetic energy? Okay, so the kinetic energy can be solved using the formula 1/2 mv squared. Again, kinetic energy is 1/2 mv squared, wherein your m is the mass of the object, v squared is the resultant velocity. Please take note that the velocity v is the resultant velocity. So for example, you have for example, kaning mass 1, kaning green nga ball, ang inyong gamiton nga velocity sa iyang kapag solve sa kinetic energy would be 1 squared plus 0.3 squared, then kuhaon ninyo ang square root. So that is 0.3 squared plus 1 square root. So that is 1.044 meters per second. Again, please compute and then kinahanglan makuha ninyo ang 1.044 para sa velocity of mass 1 or mass A. Kung dili niyo makuha, please pangutanan mo na ako, ha? Kung dili niyo makuha. Okay? Balik sa procedure sa buhaton. So we have to compute for the kinetic energy. So na kay velocity, na kay mass, you can now compute for the kinetic energy. Inyong i-fill out in table and you have to show all your computations sa inyong lab report. The last question is, can kinetic energy be transferred from one body and to another? The answer is yes. Because if we will click here the kinetic energy value, 0.65 joule, when they collide, what happened to the kinetic energy? Wala siya na change. Because kinetic energy is basically energy. It will not be, it will be conserved. So it will only transform from one form to another. It can be transferred from one body to another, but it will not be lost. Okay? Lastly, last na ba ni? Hindi pa rin. Number 17, using the data taken in each set, fill out the table below and show your solutions in the lab report. So we are going to compare the momentum before and after collision and for both elasticity settings. Diba, giset nato ganiha og 100%, ato pong giset nga 5% ang elasticity. So atong butang diri nga table ang mga momentum lang. Before and after collision. May nakabutang before, after collision. And we have to compare. Kung sa may mahitabo sa ilang momentum. No? But basically, what we want to prove here is ang ilang momentum is dili mag-change. Or mag-change siya, but the sum of the momentum will still be the same. So, imong i-add ang momentum sa kaning duha ka balls or sa kaning ball 1 plus ball 2, makuha nimo ang same na momentum. Okay, so this is the general instruction. However, as what we have discussed during the class orientation dili ni mao ang atong gamiton nga kanang subject. So una atong unahon ang inyong last name, full name, last name, first name, middle initial, lab exercise number 2 before you submit it to me. If you cannot submit this lab report sa VSU EE, you may submit them through my email at daniel.lore@vsu.edu.ph. You can also explore these references for additional information about the topic of momentum. And before or after this table 4, kung sa may last nga buhaton, you have to insert here your conclusion. So kung sa may atong ibutang sa conclusion, the conclusion should contain the answers to the following learning outcomes. So, how to compute for the momentum of an object, how to compute for the resultant velocity of a colliding object, and differentiate the momentum of objects with varying elasticity. So for our simulation, we used 100% elasticity and 5% elasticity para ma-compare yun nato sila totally, no? And you have to answer, or you have to answer here, to answer this last question, how to compute for the kinetic energy given the mass and velocity. Okay, so if you have questions, just don't be hesitant to send an email to me or send a chat sa akong personal messenger nga account. Okay, thank you. So this is, if you have questions or clarifications regarding the simulation, just message me. Okay, thank you, and this ends my discussion this morning. Have a nice day.